Today on NerdOut, wallet cracking. Welcome back to NerdOut, the show where we take a look at Cardano, we break it down but don't dumb it down. Today we're talking about a topic I spent a little bit of time on over the weekend. We're talking about wallet cracking. So let's jump into it. So what is the problem? The problem is somebody has their Cardano wallet, they have forgotten their password, and they've also lost their seed phrase. What is the best way to do things? Obviously, a hardware wallet will keep the private key on the device. That's the safest. If you have a software-based wallet, how they work is they keep the private key of that wallet encrypted with some password. If you forget both the password and the free seed phrase, you are SOL. But if you can guess the password, then you can potentially recover the wallet and move it to something else where you do have the seed phrase. So this scenario, about a year ago, a Cardano user contacted me. They had an old Eternal wallet. They had lost the password and seed phrase for. This wallet only contained personally valuable stuff, so they were willing to share the encrypted private key with me. And old Eternal uses this algorithm. It uses PBKDF for a key derivation function with HMAC SHA-512 hashes. And then the wallet, once you've derived the key, then it is encrypted with CHA-20 poly 1305. One of those is like doing a it's doing a checksum, and then the other is the actual encryption, but those are usually used together. And so they wanted to see if I could crack it. So about a year ago, I started working on a little Rust program. And so this is code I produced a year ago. It takes the data. So I created a dummy wallet that I did know the password for, so I could test whether my scenario worked or not. So I created an old Eternal wallet with the old algorithm and with a password that I would know. And then I derived the key for it and was able to successfully decrypt that. But essentially, the key derivation, that PBKDF, that is the thing that makes it hard to crack. That's the thing that requires a lot of work to get to. And that's this derive key function here. And it's doing the PBKDF derivation, and the iterations is what really protects your key and makes it difficult to go through many of them at a time, because this, takes maybe a second or two per password. And as you can imagine, if you've got millions to go through, then it's going to take an infinitely long amount of time. And of course, if you have a longer password, that's more things that a cracker has to check. So short password, your wallet's getting cracked. Longer password, nearly impossible to crack without quantum computers or something like that. So this is where I started. Again, this wasn't very successful a year ago because it just didn't have enough power with using the CPU to run through enough tests password to guess the password. So last weekend I did a little project. I've always wanted to do some GPU coding. Hashcat is a GPU password cracking tool. It utilizes OpenCL and C code. So OpenCL sits on top of whatever the hardware uses. So like an NVIDIA card will use CUDA. If you have Radeon, it'll use ROCm. OpenCL kind of sits on top of that and is a layer where you don't have to worry about as much of the underlying stuff. I don't know OpenCL, and so I reached out to an LLM to help me solve this problem. And I gave it my Rust example code, and I gave it a ton of encouragement, and I wanted it to implement CHA-20 and poly 1305 in OpenCL. The reason for those two, they did not yet exist in OpenCL. There were already algorithms for PBKDF because a lot of different password schemes already use that standard. So I often found that it got frustrated trying to make things work, but with enough perseverance and guidance from me, it finally figured out the scenario, and it could like look at the examples in RFC for those algorithms, and we could verify that those were verifiably correct. I know it's kind of weird, and I know it's not a human, but it seemed to help to give it encouragement, like telling it things like, do this thing, try this, you got this, I believe in you. And it seemed to work a little harder when I gave it encouragement. So that was an interesting takeaway. And this is some of the code it produced. This is the Cha-Cha 20 block cipher. And this is something that I probably could not have done on my own, which is really fascinating to me. Maybe I could have done it if I was willing to invest, a month worth of time and effort in really understanding the algorithm and looking at enough example code. But again, I don't know OpenCL, but I could give it test vectors to know that I could trust this code then. So what are some of the takeaways? A strong, long password will prevent cracking. That is the most important takeaway. If you have a short password, I would say 8 characters or less, change it. Go to a longer password. Also, modern Eternal, the recent, well, not even recent, for the last several years, Eternal is absolutely safe. It has very, very strong standards for encrypting your wallet with a password, but still use a long password, and better yet, use a hardware wallet with whatever software wallet you use. The other takeaway is LLMs can produce in a weekend what would have taken me a month or more to accomplish on my own. So LLMs in the past year have gotten way, 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 way better. They can do interesting things as long as they are in the hands of somebody that kind of knows the outputs that they want it to accomplish. And you can feed it enough information as to how to accomplish that task or things to try. I would suggest things like, try swapping those bits. Maybe it's a big Indian, little Indian encoding issue or things like that to get it to where it needed to be. So this code is, of course, open source, and I've put it up as a pull request so far on the Hashcat GitHub repository. So if you want to take a look at that, you can do that. I'll also probably put a link down in the description. But yeah, that should be pretty easy to type it in if you want to. And those are the takeaways. And that's all I got. I just wanted to share a fun little project I've been working on. So with that, nerd out.